Okay, now in part number 2 we have to discuss the introduction about ASC 712. Okay, the ASC 712 this is the Hall effect sensor. uh, we have to this is the Hall effect sensor. So okay, this is the Hall effect sensor. We have to discuss it. This is the internal diagram of Hall effect sensor. Okay, this one is the current input pins. This one is the current input pin. This is the current output pin. Okay, this current 1 2 and ip ip negative ip negative 1 2 and ip 1 2 is the input pin, and the positive ip plus is the ip plus is the 1 2 pin, and negative is the 3 4 pin. Okay, this is the 2 pin. Okay, now this is connected to the this IC. This IC internal structure is like this one. This is the internal IC terminal which is connecting to this Hall effect sensor. uh, when current flow in it, when current flow this terminal, when current flow this terminal when current flow this terminal, due to current the magnetic field will produce, and due to this magnetic field this is this is due to this current the magnetic field is produced, and this is working of the Hall effect sensor. So these there's an output pins of ground pin and VCC, and this is the output pin. This output pin work as a input of a analog terminal of a analog terminal of a analog terminal of a analog terminal of a Arduino. Now this we have to discuss some future. This is the circuit diagram of our simulation. This is the simulation diagram, and this one is the COM of physical port. This is the LCD. This is the Arduino Uno. This is the lamp. This one is the ammeter. This is the visual design for Proteus, which is ACS 712. And look it into here. This is the if you look into it. So if you look into this circuit, so this is if you look into it, this is pin number 1 2 positive IP, and 3 4 is the negative IP. Okay, this is the positive IP, and this one is the negative IP. So look into it. This is the positive IP. This is the positive IP 1 2, and this is the negative 3 4 pin. Positive and negative is connected to this one, and this is the output pin. So look into the circuit. This is the circuit diagram. So this is the input 10 volt, and these are the V out, which is connected to the A out of a Arduino Uno, and this is the analog sensor. So this analog is connected to the this analog input pin of Arduino, and it will run on the on the VCC DC supply. So we are going to use 5 volt to connect these this sensor. This sensor is 30A. Uh, it will produce a voltage of minus 30 ampere. It will sense the voltage ampere up to minus 30 ampere to plus 30 ampere. Okay, so there the sensitivity of, so we are using ASC ASC 712 30 ampere 30 ampere measure the current, DC current in two into condition 1, 0 to 2.5 volt, which is the offset value. Then other one is a 2.5 to 5, which is the on value. So measure the AC current by using RMS value, root mean square value. Okay, the sensitivity for ASC 712 is from 66 to 185. Sensitivity means the minimum value. So this is the coding for which you use okay. Offset is 2500, and this one is a sensitivity from 66 to 185. Okay, this is 185. So we have one formula here. This is the analog rate. So we have to discuss this point. We have to, this is the ADC value. The analog sensor, when read the analog value, it will give to the analog channel as a analog pin of A0. Okay, this is the analog pin of A0. This is the, it will read the, when it will, its output is, this is the output. Okay, this output is connected with the analog output is connected to the analog port of the UNO. So this is the output. It will read the AC, it will read the analog to DC value. It will be analog to DC value. So for 30 ampere its value is 516. This is the 516 value. So it will read the value of A0. So what is the voltage? So this, the ADC value is divided by 1024. What is 1024? This 1024 is the equal to the 2 power 10. It is 2 power 10, and this ADC value is divided by 1024. Let's suppose it is 1024. So it will be for no input, for no current, ADC value is, analog read is 516. Okay, so if we divide voltage equal to 516 divided by 1024, it's equal to 0.5, and you have to multiply this 0.5 into 5000 millivolt. So it will give you 0.5 into 5. So value is 2.5. Okay, this is the offset value. When there is no current. Okay, the value is 2.5. So the current is, the value of current can be calculated by using any voltage beyond this value. Let's suppose it is 3.5 minus 2.5 divided by sensitivity 66 milli. So the value is 1.5 divided by 66 milli. The value is 22 ampere. This is 22 ampere. So this is the main concept. So this is the analog input, and there is a ADC. ADC is built in UNO, Arduino UNO. It will convert analog input into digital, and give you an output result. Okay, this is the main phenomena which we are using in this sensor. Okay, so this is end of part